Welcome to my channel. Today I'm going to show you some of the built-in security features in Linux and how to utilize these. The intent is to give you an overview of what security features are available in Linux, which can be leveraged to make the operating system as well as applications running in it more secure and protect them from attacks. We'll start with a category of vulnerabilities which usually have the highest rating in the common weakness enumeration. That's buffer overflow related vulnerabilities. If you look at the website of CWE Top 25 for 2021, which you can find in this link, the first one is out of bounds write, which is a buffer overflow vulnerability. So we'll start with the buffer overflow problem, which is I have a sample code here where I'm trying to copy a buffer of size 15 bytes into a destination buffer of size 10 bytes, which is basically causing a buffer overflow problem. And if you see here, this is the code on the left hand side, and if I try to compile the file and I'm trying to execute it, which goes through fine. So effectively I'm causing a buffer overflow problem here, which goes through fine, does not raise any alarms. So that's a serious concern. Now GCC has a built-in feature called Fortify Source, which detects such kind of buffer overflow issues at compile time if possible, and if not possible at compile time, it can also detect certain cases at runtime as well. So make sure that you leverage the Fortify Source enhancement of GCC and compile your code with Fortify Source. So the way it works is it will detect the size of buffer at runtime or at compile time, and if possible try to raise an alarm if a buffer overflow is getting triggered at that point. A simple example I can show you here is, instead of a simple mem copy, you can replace it with a built-in mem copy. So here what I'm doing here is, instead of a mem copy, I'm replacing it with a built-in mem copy and trying to copy the same buffer of size 15 bytes into a destination of size 10 bytes. And when I try to compile this, you see I get a warning saying there could be a buffer overflow, right? So this is how we can detect buffer overflows in advance and prevent a host of such overflow attacks. Now, second category of attacks, preventing attacks is the stack smash attacks. So GCC has the F-stack protector and the stack clash protection and a host of other features. So basically what they do is, on the stack, certain stack canary or red zone is inserted every time a stack function gets stack frame gets generated. And while the stack frame is unwinded, the stack canary or the red zone is checked again. And if the red zone is intact, then it means a stack overflow has not occurred. And if the red zone is been overwritten, then there has been a stack overflow and something has gone wrong. So in this case, I'm trying to simulate a stack overflow and trying to run into a stack overflow problem. So in this case, I have a char buffer of size 3 bytes, and there I'm trying to copy a data of 7 bytes here. So if you can see, a buffer is allocated on stack, and on the stack a buffer of 3 bytes, I'm trying to write a content of 7 byte data. So if I compile this, gcc smash.c, and when I run it, so it will detect that a stack overflow has occurred. So that's the second category of buffer overflow issues which can be detected and protected. So there's another interesting enhancement called the clash protection, stack clash protection. So basically what happens is, the stack grows in one direction and heap grows in another direction, and there can be cases where the stack can hit the heap In those cases, that can expose a lot of vulnerabilities, and that is protected by the stack clash protection enhancement. So a third kind of enhancement is the executable space protection. In this code, I have a test function here, and I have a function pointer which is pointing to my test function. Now my test function is there in the code segment or the text segment, and when I call this text function, it gets executed without any problem. Now what I'm doing here is I'm copying the content of my function to a heap. So I'm mallocing a buffer, and I'm trying to copy the content of my code to heap and trying to execute it from heap. So basically, I'm trying to execute code from heap, which should not be prevented. I mean, which should not be allowed. Sorry. So that is what is being protected here. So if you see, I can easily call the code from text segment, but when I try to execute the code from heap, I run into a segmentation fault. Basically, it prevents vulnerabilities like return to libc kind of attacks, or certain attacks where code redirection is done, where user can copy their own code to heap and try to execute their vulnerable code from heap, or their code from heap. Those kind of attacks can be prevented with this enhancement. So this is usually present in this is an enhancement present in the Intel and other CPUs. It is enabled by default. And finally, we look at the address space layout randomization. So basically what happens is when hackers find out that certain pointers so when hackers are able to find out that they are able to, let's say, figure out addresses of certain pointers, and they are able to build an attack vector to leverage the knowledge of that information, that there are certain pointers always available at certain location, which can be used to build an attack vector. Now whenever you compile a program, it will have different segments, let's say code segment, data segment, stack segment, heap segment. Now each of these segments are located at different addresses. If these addresses are generated at fixed locations, then the predictability of pointers getting the same address is always very high. So the possibility of leveraging this information to cause an attack is very high, and that is what is prevented by ASLR, by randomizing the address space of all these segments. Say for example, in this case, I have my ASLR program. Here I have certain variables, say int x, which is created or stored in the RO data, which is read-only segment. I have swhere, which is stored on the stack. I have hwhere pointing to malloc data, which is on heap. So I have three addresses which I'm printing here. One pointer from RO data, one pointer from stack, and one pointer from heap. So let's see what are the addresses of all these pointers. gcc slr.c. Now every time I'm executing this program, I'm getting the same addresses for each of these pointers. So basically my addresses are not randomized, and since they are not randomized, an attacker can predict at what address certain pointers can come and then build an attack around that. So what ASLR does is it randomizes the addresses of all these segments so that it becomes difficult for an attacker to predict addresses of pointers. And the way that is done is, so actually it is enabled by default on Ubuntu. I had disabled it on this machine. Let me enable it. See, now when I'm executing this program, I can get different addresses for different instances of the same program. So my addresses are now randomized, and that is what is done by the ASLR program. So I'll share links which will explain you what exactly this randomized VA space means. So you can go to those links which will tell you what exactly this does. And these are just few of the features. If you go to the links which I'll be sharing in the description box, so they list down a host of a bunch of other features, like compiling data in PI format, that is position independent executables, ASLR, more details on ASLR here, null pointer dereference protection, host of other features, SE Linux, security enhanced Linux, so that applications, you put restrictions on applications that they access only those resources which they are allowed to access. Say for example, a web server should not be accessing certain databases or certain files. It should its access should be restricted to only certain number of certain directories or certain files, and nothing beyond that. Those kind of restrictions can be enabled by SE Linux. So all those features, 45 source is what I talked about just now. So all those features are listed down in these links which you can go through. There are various links for the distro which you're concerned about, whether it's Debian or Red Hat. You can look at one of these links to get more details on the security feature enhancements. Okay, so that's it for now. Thanks for watching. I hope you liked it.